Hello again, students. Welcome to the latest installation of, hey, how does a range shift system on a twin countershaft transmission work? I'm glad you asked that question because I've got an answer. This is what the range shift mechanism would look like if you were standing inside the transmission. I've taken this case off and reassembled it to illustrate how the auxiliary countershafts, the auxiliary drive gear, the output shaft, the high range, low range synchronizing clutch, the output drive gear, and the output yoke all work together to give me two speeds, a high range and a low range. Let's start with the auxiliary drive gear. The auxiliary drive gear, as you recall, is splined to the output shaft of the transmission, to the main shaft of the transmission, excuse me. This is splined to the main shaft of the transmission, and it rotates with the main shaft of the transmission. Because it is fixed to the main shaft in the front transmission, the front box of the transmission, this is considered to be part of the front box of the transmission. This is the main section. You can see the auxiliary drive gear has clutching teeth machined into the inside of it. You can see that they're really rounded off. This is well worn. This auxiliary drive gear has been around the block a few times. You can see that it has a machined cone surface on it. This would be really handy to have if I have a synchronizer that can drag on this to match the rotational speed between the main shaft and the counter shaft, or the output shaft. This, as it sits, mounted to the main shaft of the transmission, can be found engaged on the auxiliary section of the transmission like such. The main shaft of the transmission is going to be in here. Well, it's dark in there, you probably can't see, but the main shaft of the transmission comes within just a short distance of the output shaft. They don't touch. They're still two separate pieces. The main shaft comes in here, stops here. Output shaft picks up just outside of that, and continues on out the transmission. As the auxiliary shaft turns, or the main shaft turns, excuse me, as the main shaft turns, so turns the auxiliary drive gear, which causes the countershafts to turn. Both these countershafts are turning the same direction, aren't they? They're both turning clockwise. Handy. The countershafts have a large gear on one side and a small gear on the other side. The countershafts are just like the countershafts in every other transmission. They're one piece, one gear turns, so turns the other. When I turn the main shaft, I'm turning the countershafts. My sliding collar, my synchronizer, parked right there on the output shaft of the transmission. It's not fixed to the output shaft. If I was to take this output shaft out, that would easily slide right through there and come right off. This synchronizer here, is the position of which is controlled by the shift fork, which is fixed to a shift yoke, which is part of the range cylinder. This yoke right here is called a yoke bar. The yoke bar causes the shift fork to slide in and out. You'll see the sliding collar also has clutching teeth on it. You'll notice those clutching teeth, just like these clutching teeth, are well worn. Right now, this yoke has been pulled backwards. That sliding collar has clutching teeth on the other side of it, on the back side of it, that are currently engaged with the output drive gear. My output drive gear right there, got the little white dots on it. Those are for timing purposes. We'll talk about timing at another time. So now I can easily see that the output gear is locked to the output shaft. So if I turn the counter shafts are going to cause the output drive gear to turn. That output drive gear is going to cause the shaft to turn through that sliding collar. The range cylinder is supplied air from the slave valve through a couple of rubber hoses. When I put air to one side of that range cylinder, it's going to cause this yoke bar to move. It's either going to move backwards into low range or forwards into high range. Right now I'm in low range. Let's put some air to it and see if we can't get it to come into high range. Let's see what happens. Look at that, it did. This came forward, this sliding collar came forwards and has now, or would have now, engaged in the auxiliary drive gear. This auxiliary drive gear splined to the main shaft is going to provide a 1-to-1 ratio between the front box and the back box. Now it seems that I can turn the output shaft without turning the countershafts. The countershafts are turning freely. They're still engaged with the output drive gear, but the output drive gear is no longer locked to the output shaft and doesn't provide any torque. At this point in time, the auxiliary drive gear is locked to the output shaft. It's also splined to the main shaft of the transmission. So as the main shaft of the transmission spins, so spins the output shaft of the transmission, because I'm in high range. Countershaft is still going to rotate because it's still splined to the gear. If I take this gear off, no more torque is being supplied, no rotational force is being supplied, so they don't turn anymore. Of course, that's not the case inside of a transmission. It's always going to look like this. In high range, that's what it looks like. Put it back in low range. And I can turn the yoke, but the output shaft doesn't turn nearly as fast. I'm sorry? Oh, you want to be able to see it? Okay. All right. Let's try this. I'll turn this at a steady speed. I'll tell you what, I'll turn this 1 revolution, okay? That was 1 revolution. Remember now, I'm in low range. 1 revolution. The torque is coming from the main shaft into the auxiliary drive gear, out the auxiliary drive gear into the counter shafts, back to the output drive gear. The gear reduction occurs right here. Got a big gear, small gear turning a big gear, small gear turning a big gear. I'm going to have an underdrive situation created. So let's put it in high range. Launch that auxiliary drive gear right out of there. Now, when I turn this 1 turn, you can see easily that the relationship between the input gear, auxiliary drive gear, and the output gear, the yoke, is a 1-to-1. That's all the harder this is. The air circuit that makes this work includes a regulator, range cylinder, a slave valve, and a master control valve. We'll talk about those in another video. Hey, thanks for joining me. I appreciate your time.